We did yesterday. We talked about solving absolute value equations yesterday. Today we're going to look at solving absolute value inequalities. Let's get rid of earbuds and phones, please. So there's two different types of absolute value inequalities we'll look at today. One of them is where we've got an absolute value expression with a variable inside that's less than a number, in the other case where that absolute value expression is greater than a number. All right, so let's kind of go back to basics for just a second. What did we say the other day, right? The solution set of the absolute value inequality, the absolute value of x is less than 2. Think about that in terms of a number line, right? An absolute value of a number is telling us the distance from 0 on a number line, right? So for example, the absolute value of -2 is 2 because the point -2 is 2 away from 0 on a number line. The absolute value of 7 is 7 because 7 on a number line is 7 units from 0. So then doesn't it make sense that if we start with something like this, the absolute value of x is less than 2, then that means that all the numbers that would make that true, all the values I could plug in for x, if I were to plot them on a number line, they would have to be less than 2 units away from 0, right? That makes sense, everybody? So what would that look like? Well, would look like that, wouldn't it? Okay. So then fundamentally, when we have an absolute value involving a variable that's less than a number, we should always expect to see this kind of an answer, this kind of a result when we graph it. It's going to look like a single interval that's got endpoints to the left and the right. So it's bounded on both ends, okay? All right, so in general, we can, we could generalize this a little bit and we could say we don't have to have just the variable x inside. Just like yesterday, we could do something where we're going to instead trade that for a capital X or maybe a U, same thing. They imply the same thing. And that is some expression involving X. It could, it could be more complicated than just a variable X. It could be 3x minus 5 or 2x squared plus 4, something like that, right? Some expression that involves X's. But anytime we have the absolute value of some expression in X and it's less than a number, it always ends up being this kind of a bounded interval, bounded on both ends, right? And we could say that it's always equivalent to this statement. Whatever's inside the absolute value expression is going to be greater than negative a, where a represents whatever number's outside, and less than positive a. So we're trading it for a compound inequality that's an and inequality, right? Okay, so we want to make that association. If we have an isolated absolute value that's less than a number, we're going to trade that absolute value inequality, which we can't really do algebra with because it's still got absolute value bars, right? We're going to trade that for 2 regular inequalities. Isn't that what we did yesterday, right? Same pattern. If we had an absolute value equation, what'd we do with it? We traded the single absolute value equation for 2 separate regular equations that we could easily solve. Didn't we always just split it, right? Same thing today. We're trading a single absolute value inequality for 2 regular inequalities that just happen to form an and compound inequality. Compound just means more than one, right? Okay, so what are we going to take? Let's apply this. Before we move on, you guys probably are aware of this. Just like yesterday, before using an absolute value inequality property, we have to isolate the absolute value, right? So if I wanted to do something like this, well, in this case, the absolute value is already isolated. We'll look at some other examples where maybe it isn't. Okay, but we've got an isolated absolute value. Instead of x's, we've got n's this time. So what am I going to do? What's my first step? Split it in 2, okay? And this fits the profile of the one we just did, doesn't it? This is going to split into an and inequality. Now again, I'm going to use these icons up here where I'm using a U because that's what you're going to see in calculus. Capital X is fine. That's what our textbook uses. But if I have an isolated absolute value of U is less than A, that splits into our and pattern. Okay, so we're going to get that, right? And from there on out, it's easy, right? Now it's the stuff you've already been doing. We're just going to solve that compound inequality for n. Okay, so just, I mean, we've already done stuff like this. What would my next step be? Subtract 7 from all three parts, right? Then what? Divide by -4, which means I have to do what? Good, I've got to flip the inequality. And then if I divide by 4, that's going to give me my -5. Over here, I could simplify the fraction. -34 over -4 would simplify to positive 17 over 2, right? And then what's my last step? That looks goofy. I got to turn the whole thing around, don't I? So the inequality is always open to the right. We don't want to have an and inequality where they're going backwards like that. So we'll flip the whole thing around and we're done. Okay, give me thumbs. Is that all making sense? Okay. Okay, let's look at the other type and then we'll look at some more examples. So what happens here if we've got where the absolute value inequality is such that the isolated absolute value is greater than a number? We'll take an example. What if we start with a simple one? The absolute value of x is greater than or equal to 3. Well, what's that solution set going to include? That's going to be all values of x that are 3 or more units from 0 on the number line. Okay, doesn't that look like this? Right? I could have units that are 3 or more away from 0 going in the negative direction or the positive direction, right? Either way. But so I get a characteristic look here where I've got, that looks like an or compound inequality, doesn't it? Remember, that's like the oars on a boat that are rowing towards you, sticking out to the side. Okay, so then this tells us that whenever we have an isolated absolute value expression greater than a number, this single absolute value inequality is going to, again, split into two regular inequalities in the form of an or inequality, though, right? So the pattern is whatever's inside the isolated absolute value is either going to be greater than the positive number or less than the negative number, right? It's got to be to the left of the negative endpoint or to the right of the positive endpoint. Okay? So let's try an example. What about something like that? What do I have to do first here? I got to add 6 because I have to isolate the absolute value, don't I? Good. So we add 6 to both sides. Those guys cancel, and I get the absolute value of -3x plus 21 is greater than 24. Okay, how am I going to split that one? That and or? That's going to split into an or, isn't it, right? So whatever's inside, we're just going to follow this pattern. Whatever's inside the absolute value is either going to be what? What's one possibility? What's inside is greater than 24, or what's inside is what? Less than -24. And what's inside is -3x plus 21. So look, now we've just got a compound or inequality, and we'll just solve it like we always have, right? We just do each one individually. So what would my steps be here to isolate x? Subtract 21, so I get -3x is greater than 3. divide by -3, which means flip the inequality. So I get x is less than 3 over -3 is -1. Or same steps over here. If I subtract 21, everybody agree, I get -3x is less than -45. If I divide by -3, I've got to flip the inequality and I get x is greater than 15. So there's my final answer. Either x is less than -1 or x is greater than 15. Okay. How we doing? Give me thumbs. That all make sense? So we got these two patterns. Here's a little summary, right? Just for your notes. I'll just leave that in the, when I publish the notes, it'll be in there. It's right out of your textbook. There's the three patterns we've talked about, 2 today, 1 yesterday. And a little quiz yourself here. If I start off with the pattern an isolated absolute value is equal to A, when I get rid of the absolute values, what's that going to give me? What equations does that give me? U represents everything inside the absolute values. So what would I get? Yeah, U equals A or U equals -A. Okay, there's that pattern, right? What's the pattern if the isolated absolute value is greater than A? And or? It's or, isn't it, right? That's an or. So what's that one going to be? Either U is greater than A or less than -A, either order, doesn't matter. And then finally, if the isolated absolute value is less than a number, and or? And? So how's that one look? Yeah, good. And that's how we say it, isn't it? We get a compound and inequality where U is greater than -A and less than +A, okay? And obviously, if any of these inequalities include equal signs, well, it's the same pattern. You just have equal signs with your inequalities, okay? All right, let's just go through a couple quick ones here. What about this guy? What do I have to do first? Okay, and what's the point? What am I trying to do? First part of this process is isolate the absolute value. Okay, so we're going to add 1 to both sides. Then divide by -4. What's that going to do to the inequality? It's going to flip it. Okay, so we end up with, even though it might have initially looked like we were going to have an and inequality, right? When we isolate the absolute value, because that inequality flipped, now we get an or inequality, right? So we're going to follow that pattern. Okay, so what are the inequalities then? What am I going to get here? Elijah, what do I get when I split this? I got to split that into two inequalities. What am I going to get? Okay, or there you go. Beautiful. Okay, and I would just solve both of those and it's a piece of cake, right? And I get my two answers. Okay, good? Good. All right, what about this guy? It looks like or, okay. Anybody see something different here? Okay, so it's negative, but we got to be careful when we're dealing with inequalities, right? Now, if this were an equation, the answer would be no solution. If we had the absolute value of 2x plus 4 equals -14, good eye, birthday boy, we would have definitely said no solution, right? Because that's impossible. But with inequalities, it may or may not be possible. So what does this mean? If I have the absolute value of something is greater than or equal to Negative, they don't both have to be true, right? It's greater than or equal to. Well, yeah, it can never be equal to, but for what values of x is that absolute value going to be greater than a negative number? Let me say that again. For what values of x, you don't even care what the expression is. For what values of x would an absolute value be greater than a negative number? What do you think? When is an absolute value greater than any negative number? Always, isn't it? Right? An absolute value output is always non-negative. Could be zero or positive, but it could never be negative, right? So wouldn't you agree that this is always true? Okay. So what's the answer to this one? Infinite, right? All reals. That makes sense because that's a statement that is always true. An absolute value always outputs a value greater than negative 14. So all reals would be our answer. Okay, give me thumbs on that. Does that make sense? Okay, so you got to just pause for a second when you see that negative and think it through with an inequality.